And for the rest of the section, we're going to look at some problems that ask you to rationalize the denominator. Okay, so this is the process of converting a fraction with a radical in the denominator to an equivalent fraction whose denominator is an integer. Okay, so basically we want to remove the radical from the denominator. That's for convenience. If you have fractions with radicals, they're usually harder to combine with other fractions. So often you want to remove the radicals from the denominator. So let's look at A. We have 4 square root of 3. So to remove this from the denominator, we want to basically multiply the fraction top and bottom by the same thing. So we want to make this a perfect square. Okay, so square root of 3 multiplied by itself and on the top also, so it keeps it balanced. That will do the trick. So we have 4 square root of 3 and then square root of 9, and then that square root drops out because we get a perfect square in there. So we have 4 square root of 3 over 3. Okay, so this is what we mean by rationalizing the denominator. You start with something with a radical on the bottom, and you want to multiply top and bottom by the same thing in order to make this into a perfect square, so the denominator is gone. So the radical is gone. All right, let's look at B. So B is square root of 3 over 20. We're going to split this up, square root of 3 over square root of 20. All right, so now here we could multiply by square root of 20 over square root of 20, but because this can be reduced, you want to do that first. Okay, so square root of 20 is square root of 4 times 5, so we get 2 square root of 5. Okay, so simplify it first. Now you can multiply just by the radical part. So multiply by square root of 5. This keeps the numbers smaller if you simplify first. Okay, so square root of 3 times square root of 5 is square root of 15. Then we have 2 times square root of 25. We get square root of 15. Square root of 25 is 5. 2 times 5. So this is square root of 15 over 10. Right, so we rationalize that denominator. All right, let's look at C. 3 over square root of 6x. This does not simplify. So we're going to multiply top and bottom by the square root of 6x. All right, so we have 3 square root of 6x over square root of 36x squared. So 3 over square root of 6x and 6x, like this. Okay, nice. That's it. That's what rationalizing the denominator is. We're going to go over a few more examples with variations and things that are cube roots and fourth roots and see how that works.